This is Unit 2. Unit 3, Triangles. Preview video 3.1, Triangle Types and Sums. Take a moment. Close your eyes. Ready? Deep inhale. Hold your breath. And exhale. Keep your eyes closed for a few more seconds and listen to the music. Take a deep inhale and open your eyes. All right, we are right here, triangle types and sums. Make sure you get a date, time, and location as well as a parental sign-off. That is worth a point. We're going to be camped out on triangles. Warning, we're going to be doing some variation of triangles all the way through Christmas time and beyond. Triangles are such a very, very, very critical aspect, not only of geometry, but of several different professional applications as well as many of your future academic courses. Let's start with the basic on the 7 different types of triangles. 7 different types of triangles. All right, acute means all the angles are less than 90. All the angles are less than 90. Let's say we had something here that was 50 degrees and 70 degrees and 60 degrees. All the angles are less than 90, right? That is a single angle is 90. Obtuse, a single angle is greater than 90. A single angle is greater than 90. Then we have here equiangular. All 3 angles are equal. That's why it's called equiangular. Those are the 4 different ways we classify by angles. Scaling means none of the sides are of equal length. Notice the hatch marks do not match. That is a notation that all the sides are different lengths. Isosceles, you have 2 congruent sides. Equilateral, lateral means side. All 3 sides are equal. You need to have these memorized. Acute, right obtuse, equiangular, scaling, isosceles, and equilateral. These are the 7 different classifications of triangles. So we're going to classify the triangle both by its angles and by its sides. So first, we're going to classify by its angles. Notice the angles here. That we have one angle that is 90. So that means this triangle qualifies as a right triangle. Now let's take a look at the sides. Notice none of the sides are of equal length, so we would call this a right scaling triangle. And the symbol for triangle, guess what, is a little baby triangle. Isn't that easy? Draw below an isosceles right triangle. Isosceles, by definition, means two equal sides. A right means you have a singular right angle. The only way you can get two equal sides with a right angle is if the right angle is squeezed between the two equal sides, like this, or like this. That is an isosceles right triangle. We're going to draw a triangle ABC with an obtuse isosceles triangle with a vertex B, so that AB is congruent to BC. So let's start by drawing the obtuse, which is a single angle bigger than 90, which that obviously is. The fact that it's isosceles means two equal sides. Now we're told vertex B, if it's the vertex in isosceles is the hinge between the congruent sides. So B must be here, and A and C, so that side length AB is congruent to BC. We have all those components in this diagram. I'd like you to follow the same process. Classify the triangles both by their sides, which would be scaling isosceles or equilateral, and by their angles. Pause the video. Do this on your own. Pause. Okay, welcome back. This first one, let's take a look at the sides. No sides are equal, so it's scaling. And we look at the angles. All the angles are less than 90, so we would call this a scaling acute triangle. Here we have two equal sides, so it is isosceles. And look at the angle. We have a right angle, so we'd call that an isosceles right triangle. Down here, looking at the sides, all the sides are different, so again, that is scaling. And we do have a right angle, so that is a scaling right triangle. Taking a look here at the sides, all three sides are equal, so we would call this equilateral. All three angles are equal, so we would call this equiangular. Now, besides knowing the fact that triangles have 7 different types, this is very important. Keep in mind we are studying triangles on what's called a flat surface. A flat surface. This is called Euclidean geometry. Because the rule I'm about to show you, when you put it on a curved surface, such as the globe, it changes this particular rule. But on a flat surface, or in relatively small areas of global scale, such as taking measurements within a city or even a state, this would be applicable. So it says this, that if you take the 3 angles of a triangle, let's physically sweep them together. So ready, sweep angle 1 over here and sweep angle 1 over here. Sweep angle 2. Sweep angle 3. The three angles of a triangle, if you were to pull them out and put them side to side like pizza slices, you're going to notice that they will always add up to 180. That is true of all triangles on a flat surface. The three angles of a triangle always add up to 180. So, for example, if this right here is a 100-degree angle and this right here is a 30-degree angle, that would be 130, and I asked you what the measure of this angle was. It would have to be 50 because angle plus angle plus angle equals 180. That's true of all triangles. Which leads us to this simple understanding. If all triangles add up to 180 and we have a 90-degree angle here, that means these two angles, the acute angles, must also, regardless of what they are, add up to 90. So in a right triangle, the acute angles are always going to be complementary, which is angle plus angle equals 90. Now, knowing this, we're going to do this problem together, and you're going to do this page with me as well. Taking a look here. First thing I'd like you to do is physically sweep all three angles. Physically sweep all three angles. Always make a thing equation before your algebra. So your thing equation here is angle plus angle plus angle equals 180. So then we circle plug chuck. We have this angle and we plug it in. This angle, we plug it in. Solve. Of course, we divide by 14. And we know 10 times this is 140. And if you take 2 more, that would make 28. So this x equals 12. Now, you're not done because this is not algebra class. Life does not end with x. So we come up here and we solve for all three angles. 3 times 12 is 36. Plus 4, that would make this 40. 3 times 12 is 36 again. Plus 9 would make this 45. 8 times 12 would make this 96. Minus 1 would make that 95. Then you can do a check and ask yourself, does 45 plus 40 plus 95 equal 180? And it does. That's how you know you're correct. Taking a look here, Notice the little arrow feathers. That means these are parallel. We are told that the measure of angle 5 is 70, and that the measure of angle 4 is 45. Find all possible angles. So there's two things you need to watch out for here. The two things are the fact that this triangle, angles 1, 2, and 3, add up to 180, but also you have parallel lines in play. So you can do this, armpits of the Z. So if this is 70, this right here is 70. Going this way, armpits of the Z. If that's 45, this is also 45. If I want to get this last 3, I can do it one of two ways. Either it adds up to 180 like this, or it adds up to 180 because of the triangle. So I'm going to go 180, 45, plus 70 is 115. So I know my last angle there is 65. In this page, this is what I'd like you to do. You're going to find the missing third angle, which is in blue. I want you to trace along the dotted line, and then I want you to find this exterior angle as well after you find the blue. Do this on your own. Do this now. All right, welcome back. So your first was to find this third angle, the blue angle right here, and 40 plus 80 is 120. And you take that away from 180 and you got 60. Then you found this exterior angle. That's a linear pair, that this must be 120. Right here, 75 and 35. That's going to be 110. That means this angle right here must be 70. Take that away from 180 and you find that this exterior angle is 110. Notice there's a pattern here. These two interior angles add up to the exterior angle. These two interior angles add up to this exterior angle. This is also based on triangles add up to 180. These are called exterior angles. Let me show you what exterior angles look like. Extend each side clockwise. So clockwise, we're going to the right. Extend, extend, extend. Now sweep to the right as well. Those are called exterior angles. You can see those clockwise, or we're going to go counterclockwise, which is to the left. Watch. Extend, extend, extend. Now we're going to sweep to the left. Those are also called exterior angles. And the simple property here is that if you have an exterior angle, any single exterior angle, so in this case that would be angle 4, it equals to the sum of the opposite interior. Opposite means far away, but inside. Interior. So angles 1 and 2 are going to add up to angle 4. Taking a look here, again the rule is the exterior angle equals the sum of the two opposite interiors. So angle 6, the two opposite interiors of angle 6 are 2 and 3. If you had 9, notice 9, it is exterior as well. The two opposite interiors, opposite but interior, are also 2 and 3. Angle 4, the opposites are going to be 1 and 2. So angles 1 and 2 would add up to 4. Same thing with 7. The opposite interiors would be angle 1 and 2, would add up to angle 4. You pause the video and do these two on your own. Pause the video, do this on your own, and restart. All right, welcome back. Let's check your work. You should be switching to a red pen. Angle 5 is going to equal to angle 3 and 1, or 1 and 3. Same thing. Add it up together. And angle 8 is also the sum of angle 1 and angle 3. Down here, find the measure of angle A. You should have done this, that angle A plus angle B on the inside equals 115 on the outside. So this here was unknown plus 79 equals 115. So our unknown is 36.